This is topic 6, classified paper 4, topic 6, chemical reactions. Hydrogen gas react with iodine. The equation is shown. The reaction is reversible and can reach equilibrium. This is a very common question in exam. They ask, define the term equilibrium. What is meant by the term equilibrium? The term
The
equilibrium.
forward reaction and the backward reaction are produced at the same rate.
So that is one mark. If you say rate of forward is equal to rate of backward. What is the second point? Page 11.
Of constant temperature.
No. Rate of forward reaction is equal to rate of backward. That is one mark. What about the second mark? The second is no change in the concentration of reactant and product. Like amount of the product and the amount of reactant will not change. We are not saying amount of reactant equal to amount of product. What we are saying, amounts will not change. Let's say you was having, say, 2 grams of the reactant, example, let's say, and you was having 5 grams of a product. So when it reached the equilibrium, out of 2 grams, when 1 gram is forming the product, same time 1 gram will form back the product reactant. So the forward and the backward happens with the same speed. That's why the amount of reactant product does not change. That is the condition of equilibrium. That's how you score 2 marks. 1 mark, rate of forward equals to rate of backward. The second mark, there is no change in concentration. But don't write the amount of reactant equal to amount of product. That is wrong. We don't say amounts are same. We say there is no change in their amount. Amount can be same, amount may be different. We don't know about that. So you have to learn and memorize this definition of equilibrium, and every year you will find.
Every
variant you will find discussion. The next is the graph shows how the pressure affects the yield of hydrogen iodide, like how it changes the amount of hydrogen iodide. If you are changing a pressure, does it affect the amount of hydrogen iodide?
No, sir.
No.
No. So what it shows, because if the pressure is not affecting the equilibrium, it means the moles of the reactant are same as the moles of product. Whenever reactant product have the same moles, there is no change, no effect of pressure. As you can see here, 1 mole of hydrogen and 1 mole of iodine. What is the total number of moles? 2. And how many moles of hydrogen iodide? 2. So for a reversible reaction, if you have equal number of moles of reactant, 11. For a reversible reaction, if you have equal number of moles of reactant product, gaseous reactant product, there is no effect of pressure. Gaseous reactant. It can be solid and gas, then definitely it will affect. But if we have equal moles of the gaseous reactant, the pressure is not affecting the equilibrium. Even you increase the pressure or decrease the pressure, it will not balance or shift the equilibrium. Otherwise, normally what happens when we increase the pressure, equilibrium shift towards side of less moles of the gas. And if we decrease the pressure, equilibrium shift towards side of more moles of a gas. Is it clear? So what if they say, if we were having a reaction, let's say A was reacting with B and it is forming C. So A is a gas, B is a gas, and C is also a gas. How many moles of the reactant here?
2.
So how many moles of reactant? 1 mole of A and 1 mole of B. So 2 moles of reactant. How many moles of gaseous product?
1.
1. So what is the effect? Remember this, because this is related to memorizing the effect of pressure on the equilibrium. So if we increase the pressure, So if you increase the pressure, where the balance will shift, it will shift towards side of less moles. Which side we have less moles here? So it will shift towards the right hand side or forward in this case. So increasing a pressure always shift the equilibrium towards side of less moles of a gas. And if we decrease the pressure, it will shift towards side of the more moles of a gas. So in this example, related to this example, where it should shift toward left or backward. Okay. That is how the equilibrium is affected by the pressure. It's a fixed rule. You have to learn this rule that increasing a pressure shift the equilibrium towards side of less moles and decreasing a pressure shift the equilibrium towards side of more moles. According to this question, if we increase the pressure, it should shift towards right. And if we decrease the pressure, it will shift towards left. But what if we have the same number of the moles? Like as you can see here, we have same number of moles, like 1. So total, how many moles of a gas? 2. And how many moles of a product? 2. So whenever you have equal number of moles of reactant product, that type of reversible reaction is not affected by changing pressure. Even you increase pressure or you decrease pressure, the equilibrium or the balance will not shift or change. Yes.
How does the pressure affects the yield of a product?
Yield of a product, if equilibrium shift towards right, it means the yield increases. Amount of product increase. If equilibrium shift toward left, yield will decrease.
Yields will start
Amount of product. So the graph shows how the pressure affects the yield of hydrogen iodide. Two different temperatures. Okay. Explain why the yield at 500 does not change as the pressure is increased. So why yield is not changing even we change the pressure? So what is the answer here? The same thing,
Same
because
number
we
of
have
moles.
we have to mention same number of moles of gas. For reactant and product, or equal number of moles of reactant and product. That's why the changing pressure is not affecting the equilibrium. What can you conclude from the difference in the yield? Yield means amount of a product here, hydrogen, at two different temperatures. Look, when the temperature is, just recall one thing about the effect of temperature on the reversible reaction. If we have an endothermic reaction and the overall reaction is exothermic. For endothermic reactions, if we increase the temperature, the yield or the equilibrium will shift towards the right hand side. And what will happen to yield? The yield will increase, because whenever equilibrium shift towards right, the yield or amount of product increase. If we decrease the temperature, where the equilibrium will shift, it will shift towards the left hand side. And what will happen to yield? Yield will decrease. For exothermic reactions, if we increase the temperature, where the equilibrium will shift? Left.
Left.
And what will happen? The yield will decrease. And if a reaction is exothermic, if we decrease the temperature, the equilibrium will shift towards the right. And what will happen to the yield or amount of product? It will increase. So this is a rule whenever a reaction, because reaction type is fixed, it will not change. So either a reaction will be endothermic or exothermic. Now, by looking at these two, one is at 700, another one is at 500, which is having a greater yield, 500 at low temperature or high temperature? At which temperature we have a greater yield of hydrogen iodide? Low temperature. So means when we decrease the temperature, when we are decreasing a temperature, the yield is increasing. What kind of reaction is this? So when we decrease the temperature and the yield is increasing. So decreasing a temperature, yield is increasing. So what this give an idea? This give an idea that this reaction is exothermic. So from this information,
There is no yield means product.
yield means amount of product. So when we decrease the temperature, the yield or the amount of product is increasing. So what it gives an idea, this gives an idea that this reaction is exothermic. So here, the forward reaction is exothermic. So what can you conclude by the difference from the difference in the yield of hydrogen iodide at 2 temperature, and explain your answer. So what it shows? It shows that when we decrease the temperature, the yield increases, which shows the forward reaction is endo or exo. So it will be exothermic, because that is a rule for any exothermic reaction. If you decrease the temperature, the yield will increase. That's a fixed rule. So in chemistry, a lot of things are there to memorize. Like you have to memorize these rules, like effect of pressure, effect, especially for reversible reactions. Next is the graph shows how the concentration of a hydrogen iodide changes after hydrogen gas and iodine gas are mixed together. So concentration of a hydrogen iodide, first it was increasing and then it become constant. When is the rate of a reaction fastest? Which point?
During the start. Beginning.
At the start.
So at the start. And how we identify? Because it is much steeper, like the maximum gradient at the beginning. So means at the start, the rate of a reaction is fastest. The reaction was repeated at same temperature and pressure, but in the presence of catalyst. We use a catalyst. Draw on the graph the same axis to show how the concentration of hydrogen iodide changes in the presence of catalyst. So what is the effect of the catalyst? Catalyst can alter the rate of reaction, but they will not change the amount of a product. So if I want to draw, is it right, the use of catalyst? Yes or no?
Yes.
Is it
No,
correct?
no, no.
No, that is not right,
Yes,
because
it is
I
correct.
reduces increase. If we use a catalyst, it
Yes.
increases the rate. So what I should do, I should draw steeper, but final product should be same. And we'll label that as 2. So because catalyst speed up the reaction, so it will be steeper, greater slope. The mixture of a hydrogen gas and iodine gas is allowed to reach equilibrium. Increasing a pressure of a gas increases its concentration. State and explain effect of increasing a pressure on rate of forward reaction. Rate always increases with pressure. Not, look, two things are different. One is rate, the speed. Another one is shifting of equilibrium. Equilibrium will not shift. Equilibrium remains same because the number of moles of reactant are same as number of moles of product. But when we increase the pressure, what will happen to rate? If anything is subjected to high pressure, let's say this was original, and these are the particles of the reactant. So these are the reactant particles. But when we increase the pressure, so as a result of increasing pressure means the particles will come closer to each other.
Reaction will increase.
So what will happen to the rate or the speed of a reaction as the particles come closer to each other? So the rate of reaction will increase. So rate, state and explain effect of increasing a pressure on the rate. So what will happen? The rate will increase because more collisions between the particles at high pressure. So remember the things which affect the equilibrium and the things which affect the rate. There are 5 parameters which affect the rate. And there are 3 parameters which affect the equilibrium. What are the parameters which affect the rate? Rate can be affected by concentration. Rate can be affected by temperature. Rate can be affected by pressure. Rate can be affected by surface area. And rate can be affected by catalyst. If I use any of them, so these all factors affect the rate. If I increase the concentration, the rate will increase. If I increase the temperature, rate will. If I increase the pressure, rate will increase. If I increase the surface area, rate will increase. If I use a catalyst, the rate will also increase. So catalyst is a substance which alter the rate of reaction without chemically used up. But which factor affect the equilibrium? Equilibrium is affected by only 3 of the factor: concentration, temperature, and pressure. And you have to learn what are the, like how it affect the equilibrium. For concentration, if we add reactant, this is a rule. If we add reactant, I'm writing in short R, or we remove product, where the equilibrium will shift towards the right hand side. If we add product or we remove reactant, where the equilibrium will shift towards the left hand side. What is the effect of temperature? It depends on what kind of reaction we have. We may have endothermic reaction or we may have exothermic reaction. For endothermic reaction, if we increase the temperature, where the balance will shift, it will shift toward the right hand side. If we decrease the temperature, where the balance will shift, left hand side. For exothermic reactions, if we increase the temperature, it will shift toward the left. And if we decrease temperature, it will shift towards right. Fixed rule. And for pressure, it's only valid for the gases. If you increase the pressure, it will shift towards the side of less moles. And if you decrease the pressure, it will shift towards side of more moles. So these are the fixed rules for the equilibrium. Okay. So as the question was about the rate, so we just use the concept of the rate here, that because we are increasing a pressure, so what should happen to the rate? The rate will also increase because there will be more collisions per unit volume. As a particle, more particles in a unit volume, so higher rate.
Then how does removing the product make the equilibrium go right?
Because you will have more reactants, so they will collide and form more product.
Okay.
Like rate of forward reaction will increase. Pressure is only valid for gases in equilibrium. State and explain the effect of increasing a temperature on rate of reverse. Rate always increases. Even it's a forward or a backward reaction, rate will increase. Because they ask for rate. So if we increase the temperature, so it's a structure answer. When we increase the temperature, what happened to speed of the particles? Increase in temperature will increase the speed and kinetic energy of the particles. There will be more particles with energy greater than activation. And as a result, what will happen if more particles with energy greater than activation energy, they will collide often. Collision frequency, you can also say, increases. So at the last, the rate will increase.
Oh.
Yeah, it's usually 3 mark, 4 mark question they ask this. So you always write this structure answer about the effect of temperature. Sometimes the same question is of 3 marks. Some papers it is of 4 marks, but the same answer. Increasing a temperature, increase speed or kinetic energy. More particles have energy greater than activation. The collision frequency increases, so rate will also increase. Is it-